Top preprocessing methods for LLM success. Discover key preprocessing techniques to clean and structure data for enhanced large language model performance. Did you know that approximately 80% of a data scientist's time is spent on data preprocessing? Welcome to Top Preprocessing Methods for LLM Success. In this video, we'll uncover the secrets to enhancing large language model performance through effective preprocessing. From reducing noise to structuring data, these techniques are crucial for optimizing LLM workflows. Stay tuned as we dive deep into the essential strategies that can transform your data processing approach and significantly boost your model's efficiency. Let's get started. Data cleaning is the cornerstone of any successful NLP project. It involves identifying and correcting or removing inaccuracies and inconsistencies in the data. This process is vital because even the most advanced models can be led astray by noisy data. By cleaning the data, we ensure that the model receives clear, structured, and reliable input, ultimately enhancing its accuracy and performance. Techniques such as deduplication, filling missing values, and removing irrelevant data are commonly used to achieve this. Effective data cleaning not only improves the model's results but also boosts training efficiency, making it a critical component of LLM success.
Text normalization is an essential preprocessing step that involves transforming text into a standard format. This process includes converting all text to lowercase, removing special characters, and normalizing contractions and spelling variations. By doing so, we ensure that the text data is consistent and free from variations that could confuse the model. Normalization helps LLMs understand and process text more effectively, leading to better performance. Imagine a scenario where texting, and textin are all normalized to texting, making it easier for the model to recognize patterns and make accurate predictions. Stopwords are common words like the, is, and in that appear frequently in text but carry little meaning. Removing these words can significantly reduce the dataset's size and improve processing speed, without sacrificing the quality of the data. However, not all stopwords should be removed in every context, as some might hold importance depending on the task. Techniques like using language-specific stopword lists and customizing them based on the project's needs can optimize this process. Tools like NLTK and SPA-SCI offer efficient methods for stopword removal, ensuring that your data remains relevant and concise for LLM training. Punctuation and special characters can often be a double-edged sword in text data processing. On one hand, they can provide valuable context and structure, while on the other, they can introduce noise. The key is to determine which characters are essential for the analysis and which can be safely removed. Techniques such as tokenization can help in splitting text into meaningful components, allowing for the selective removal or retention of punctuation. For instance, while punctuation may be crucial in sentiment analysis to detect tone, it might be redundant in other NLP tasks like topic modeling.
Text augmentation involves generating new data from existing text to increase the diversity and size of the dataset. This technique is particularly valuable when dealing with limited data, as it helps improve the robustness of LLMs. Common methods include synonym replacement, random insertion, and backtranslation. By augmenting the text, we can simulate various scenarios and contexts, enabling the model to learn from a broader range of examples. This process not only enhances the model's performance but also reduces overfitting by providing a more varied dataset. Implementing text augmentation requires careful planning to ensure that the generated data remains realistic and meaningful. Creating preprocessing pipelines is essential when working with large datasets, as they streamline the process and ensure consistency. A pipeline typically includes steps like tokenization, normalization, stopword removal, and vectorization. By automating these steps, we can handle large volumes of data efficiently, reducing manual intervention and the risk of errors. Tools like Apache Spark and TensorFlow Extended offer robust solutions for building scalable preprocessing pipelines. Let's consider a case study where a company processes millions of customer reviews. By implementing a preprocessing pipeline, they can quickly clean and prepare data, allowing their LLM to generate valuable insights.
Real-time preprocessing presents unique challenges as data is continuously generated and must be processed instantly. This requires a balance between speed and accuracy, ensuring that the data remains high quality without introducing latency. Solutions like stream processing frameworks, including Apache Flink and AWS Kinesis, are designed to handle such scenarios efficiently. These tools enable real-time preprocessing by allowing for on-the-fly transformations and filtering. A practical example is a social media platform analyzing user comments in real time to detect trends and sentiment changes. By overcoming these challenges, businesses can gain timely insights and respond swiftly to emerging patterns. Automation in preprocessing is a game changer, offering efficiency and consistency in data preparation. Several tools are available to automate various preprocessing tasks, each with unique features tailored to different needs. Popular choices include NLTK, SPA-SCI, and GenSim, which offer functionalities like tokenization, stopword removal, and more. These tools simplify the preprocessing pipeline, enabling data scientists to focus on model building and analysis. When selecting a tool, consider factors like ease of integration, scalability, and community support. For instance, SPA-SCI is known for its speed and accuracy, making it ideal for large-scale projects. By leveraging these tools, you can automate repetitive tasks and enhance your LLM workflows.
As we wrap up, let's recap the top preprocessing methods that are crucial for large language model success. From data cleaning and text normalization to handling stopwords and building preprocessing pipelines, each technique plays a vital role in enhancing model performance. By mastering these methods, you can significantly reduce noise and improve data quality, leading to more accurate and efficient LLMs. Now it's your turn to implement these strategies in your workflows and see the difference they make. Don't forget to like, comment, and subscribe for more insights. Share your thoughts and vote on future topics in the comments below. Until next time, keep preprocessing for success.